So in this tutorial, I'll be telling you about linear regression and the algorithms related to it. So we have a very famous example here, which is basically your house price prediction. So on before going to the formulas, I'll just tell you the basic, um, the values, whatever the variables are, and the meaning of those variables. So we'll be using M. So this M is basically number of data sets. So data set is basically so you have this one and then this value. So this forms one data set, and then you have this one, this. So this three data sets, fourth data set, fifth data set. So um, you have two parameters here. One is your size of house in square feet. The second one is price in $1,000. So basically, if the price is given as 220, which means the price of the house will be 220,000. So which is 220k, then 300k, 380k, 450k, and then 500k. Um, so before going to the squared error function or the cost function, this one, so we'll be telling you about uh, h naught or h theta of x. So h theta of x is basically called the hypothesis, and this hypothesis is one of the variables in the squared error function. So what this does is, this has two parameters, theta naught and theta 1. So what these theta naught and theta 1 are, these are basically parameters which you will be plotting in a graph. So let's say theta naught 1, then theta 1. So this theta naught and then theta 1. You will be using these two parameters, and you will be giving these two such values so that when you solve this, uh, the value, the difference between this one and this one should be as less as possible. So if your value is more, your prediction is not going to be close to what the actual prediction is. So you will be plotting values. Let's say there's 1, 2, and then 1, 2, 3. So these are basically, so once you plot, let's say you give theta naught value as 1 and then theta 1 value as 0.5. So your graph is basically, so it starts from 1 and then 0.5. As it increases, there you go. So this will be your plotted point here, this one. And let's say your value is 0.5 and then this one is 2. So your value will be, your plot point would be, it will start from 0.5. So this one, so 0.5 is here, and then it'll start from 0.5 and it will jump 2 places in slope. There you go. So this is your plot point. So 2.5 is here, and then this will be 1. So this is another plot point. So if you have several data sets like this, you can plot as many points as possible in the regression graph, not in the hypothesis graph. I'll come to that later. So let's assume that you have found out these functions, this hypothesis, and you will be using something called as a minimizing function, which is basically a summation of, sorry, I messed up. Yeah, this will be multiplied by 1 by 2m. So m is your 5 here, which is your number of data sets, and uh, h theta x is basically this hypothesis which we already discussed here. And then I will be the ith data set. So let's say um, this data set, sorry, 1400 and then 380, this data set is I equal to 3 because it is a third data set. So you'll be using the h theta of x uh, subset I, so which is basically um, x to the power of 3 here. So once you input, so the value you get here, the point you get here, minus your y value will be the output here. So y value of output, which is I, is basically 3, right? So y value is 380. So y value is 3 here. So y 380 here. And then the I value is 3. So once you have found the points, the the difference between these two, that is this one and then this value, that is 380, should be as less as possible, such that your prediction is as close as possible. So basically you subtract this and then you square the difference of these two. That is what the name suggests, right? It's the squared error function or the cost function. So once you do that, you will be able to plot these kind of points here. So these are basically, um, this is the linear regression line, and these are the points. So basically what you do is, um, once you plotted these many points here, you will be finding the difference between the values. That is what I said here, right? So h theta of x minus y, so h sorry so h theta of x is this, and then y will be the difference between the linear regression line and then your, so the difference is depicted here, the square of the differences is depicted here. This is the square of the difference between h theta x and y, square of the difference of h theta x and y, and so on. So once you find this, it will be extremely easy for you to find the prediction. So I have already got a prediction here based on R values. Um, so once you have the predictions, what you will do is, um, once again, I'll just delete this one. Um, yeah, so you'll insert a scatter plotting graph. So there you have. So you have selected these values, and then once you insert the scatter plotting graph, so you will have a chart element option here in design. So you need to select this and then choose trend line. So there you go. You have a dotted line, which is basically your linear regression line based on the values you have given in these two parameters. So let's say you want to find, the value of um, 3 380, which is your price. So 380k. So once you drag a line here on this linear regression graph, the corresponding x line would be your square feet rate. So if you can also do it vice versa,